Okay, so we've looked at positive indices. We've looked at zero indices, so when the power is zero. And now let's have a look and see what happens if we've got a negative indice. Okay, so let's fill in some stuff that we know already. Okay, I want you to, whoops, to the power 1, okay, to the power 2. Okay, can you fill in this pattern? Okay. Well, 2 to the power of 1, of course, is equal to 2, and 2 to the power of 2 is equal to 4. 2 to the power of 3 is equal to 8, because remember, we're timesing by 2 each time. And 2 to the power of 4 is equal to 16, okay, because 2 times 2 times 2 times 2 is 16. Okay, well, when we're in maths class, remember, I usually say this, and I don't know if it's something that a lot of people say, but I always find that whenever you're doing maths, you know, the whole idea of maths is to look for patterns, okay? And so what we have here is we've effectively got a pattern. If we look at this, we can say to ourselves, okay, well, what is this pattern? What's occurring? Okay, well, you know, we know each time I'm going up, okay, I'm doubling each number, I'm timesing it by 2, okay, well, that's cool. Like, we know that because that's what the index is basically doing. It's basically, you know, doubling each time it goes up. But let's think about it in reverse. What happens if I'm going back this way? Okay. So to get to 16 to 8, well, I've got to divide it by 2. Okay. And then to get to 8 to 4, well, we divide that by 2 as well. And you can see we get this pattern forming. Now we can also see this for 2 to the power of 0 as well. Now, from our previous lesson, we knew that 2 to the power of 0, well, that's just equal to 1. And you can also see from our pattern that we can get to this number by again dividing by 2. So what would sequentially come next in our pattern? Well, 2 to the power of negative 1. Okay, so 0 or 2, 1, 0, negative 1. Well, what happens when I divide 1 by 2? Because remember, we want this pattern to keep going, okay? The pattern's not going to change now all of a sudden. It's going to keep going. So dividing this by 2, we're dividing 1 by 2, when we get a half. What about 2 to the negative 2? Number in the pattern. Yeah, and we're going to divide it by 2. Get 1 over 4. Okay, because if we divide a half by 2, okay, we get quarters. If I have half a cake and I cut it up in 2 bits, how many do I have of the original? Quarters. And again, we can see this for the next number going down. We divide it by this. We're going to get 1 over 8. Okay, because we're dividing a quarter by 2. Okay, well, how does that actually help us? Well, basically what this is saying is, well, if we have a look at some of these numbers, okay, well, 2 to the power 1 and 2 to the minus 1, okay, well, they both have a 2 in them, okay? 2 squared and 2 to the negative 2, well, they both have a 4 in them, just in different spots. Okay, 2 to the power of 3 and 2 to the power of negative 3, well, they both have an 8 in there, yeah? Just in different locations. And you can probably guess where this is going. Okay, so the rule for negative indices, okay, is if you have the a to the power of some negative indices, okay, then it's just equal to 1 over whatever that number is, or letter is, and the positive indice, okay? So, for example, okay, if we had, say, 3 to the power of negative 2, then this is the same as 1 over 3 to the positive 2, okay? So you can just swap these in and out. Okay, let's see that again. Let's try another number. Let's try, let's try 11 to the power of negative 10, okay? Well, that just becomes 1 over 11 to the power of positive 10, okay? And you can see what's happening, right? We're changing it from, we're moving it so it's on the bottom of a fraction, okay? And we're swapping it so that it becomes a positive, okay? But what would happen, say, if we had a fraction where the indice was on the bottom and it was negative on the bottom? So, for example, this rule, 1 over a to the negative n, like this, okay? So notice it's a little bit different from this one, okay? In the one from above, it's got a positive value, okay? It's a positive number on the bottom. This time we have a negative. So for example, what this might look like, it might look like something like 3 to the negative 2. Or it might look like, I don't know, 1 over 11 to the negative 10. No, we won't use the same values. We'll use 1 over 5 to the power of negative 7. Okay, so see, this time we've got the negative in the bottom. So to swap this one around, okay, our rule then says, okay, well, if it's on the bottom this time, what we're going to do is we're going to just leave it by itself and put the m like that, okay? So this one would just become 3 to the power of 2, and this one would just become 5 to the power of 7, okay? So these are our two rules that we're going to be focusing on for this particular lesson, okay? So let's have a look at some examples of this in action. Okay. So example number 1, we've got 3 to the negative 2, okay? Well, you guys should be able to tell me what that is. That becomes 1 over 3 to the power of 2, okay? And we can just leave it like that, but what is 3 to the power of 2 equal to? Well, it's 9, so this is the same as 1 over 9, okay, like that. Let's try another one. Let's try this one, 5 times 4 to the negative 3, okay? Now with this one, what we need to do first is we need to put the, we need to sort out the indexes first, okay? So this is the same as 5 times what? Well, that's it, 1 over 4 to the positive 3, okay? And again, we could just leave it like this if we wanted to, okay? Or we could combine these two fractions. So if we want to multiply two fractions, remember 5 is the same as 5 over 1. So this is the same as 5 over 1 times 1 over 4 to the 3. Okay, remember the rule for multiplying fractions, you just times the tops and times the bottoms. So 5 times 1 is just 5, and 1 times 4 to the power of 3 is just 4 to the power of 3. And that's our answer there. Okay. 2 more. Let's try this one. 1 over 2 to the negative 3. Okay, well, from our rule from above, this one is just going to become 2 to the power of 3. And you know that 2 to the power of 3 is just equal to 8. Okay. Now my next one, the last one we'll do, will be 7 over 3 to the power of negative 2. Okay. So when I'm solving one like this is probably the trickiest one that we've got. Okay. I think this is the easiest way to solve these ones. Okay. Whichever number has a negative indice, we're going to move it so that it's on the opposite side of where it started. So see how this one has a negative 2 index there? So we want to move this whole guy to the top and swap it from a negative to a positive, okay? Now, the 7 doesn't have anything with him, okay? But let's say the 7 had a negative 5 there, then he would go down to the bottom. But because there's no negative there, there's nothing there, we just keep him at the top. So the 7 would stay on the top, times, okay, because there would be a times in between there, 3, and then the negative would become a positive, 3 to the power of 2, okay, and then that's just equal to, well, whatever that is. So 7 times 9, which is 63, okay, if you wanted to actually work that out. But I think we're just leaving it like this for today. And we want to see it in this form. Okay, that's it, guys. So take care, and I'll see you in the next one.